Welcome to Care Coordination and Interoperable Health IT Systems, Standards for Interoperable Health IT, Lecture E. This unit will cover the following learning objectives. 1. Explain why standards are required, how they are developed, and how adoption is encouraged. 2. Name and describe the types of interoperability standards available. 3. Summarize functionality of HL7 V2, CDA, CCDA, and FHIR. And 4. Recognize HL7 V2 messages, CDA documents, and FHIR resources. This lecture will focus on the functionality and resources for HL7 FHIR. Due to problems of HL7 version 3 and version 2, HL7 created yet a third version called HL7 FHIR. This standard came about as a result of a special HL7 test called the Fresh Look Task Force. With this task force, HL7 discovered that HL7 version 3 was too complex and that HL7 needed to modernize. The task force decided on a fresh approach to standards based on how apps are built for the web. The initial concept of FHIR is attributed to Graham Grieve, one of the many active volunteers in HL7. However, there are also other important FHIR developers at HL7. So to answer your burning question, what does FHIR stand for? Although it is spelled FHIR, it is pronounced as FHIR. F stands for fast and is in this context. It is fast to design and to implement. H stands for healthcare. I stands for interoperability, and R stands for resources. HL7 FHIR is freely available on the HL7 website. There is also additional information and free documentation on the FHIR Wiki. FHIR is designed for the web. The resource can be represented using simple XML or the JSON format, which is very commonly used in developing programs. The FHIR commands are based on the RESTful API, or Application Programming Interface, that uses the Internet, HTTP. Applications that interact with the web often use RESTful APIs. One example of a RESTful API is the Twitter API. HL7 FHIR uses the same principles. That means that a small set of operations are used, such as get a resource and post a resource. Additionally, there is a predictable URL for each resource. And for security, we use a web security standard called OAuth 2. These are well-accepted standards used in web communication, but we encourage you to do further research if you are interested in any of these characteristics of FHIR. This diagram shows how FHIR works. A system that manages data could publish an application programming interface, or API, based on the FHIR standard. The system publishing the API is called a FHIR server. Any system can now use the published API to access the data in the server, perhaps to query the data or in some cases to add or update it. The systems that call FHIR APIs are called FHIR clients. An important use case of FHIR is represented in this diagram. A mobile app helps a patient manage their healthcare information. In this case, it is about medications. The mobile app queries one or more EHRs for medication information for the patient. It uses the FHIR API of each EHR to retrieve the data. If each EHR uses FHIR, then the mobile application will not have to start from scratch with each new system it interfaces with. A fundamental concept of FHIR is that the information exchanged is communicated in small, independent components called resources. Some examples of resources are patient, allergy, and order. So in V2, the information was in segments, whereas in FHIR, the information is in what is called resources. Resources can be independently queried or updated. Sometimes resources are linked together, which could be preferable because you have the context and associations for the information. Resources are similar to V2 segments because they contain a group of related fields, but resources are different because each can stand alone and be exchanged independent of other resources. FHIR resources are simple and modular. This is the principle of FHIR. It is made up of granular resources that can interact independently or be combined together. The resources are easy to extend and to adapt. Extending means adding custom fields beyond the standard. Also, every resource contains not just structured data, but human-readable text, just like with the clinical document architecture standard. Here is an alphabetical list of HL7 FHIR resources. This shows all the different kinds of data that can be retrieved and updated using the FHIR standard. Here is an information model of a FHIR resource. You will see the fields that are in the patient's resource. As you can see, the patient resource contains demographic information for a patient. You will also see that there are several kinds of classes linked together that are all related to the patient. Note that the patient could potentially be an animal. Let's say you did a query for a specific patient. Here is an example of what the response instance would be for a patient named Henry Levin VII. The response could be represented in XML format. Alternatively, it could be represented in JSON format, which is a little bit different. Here is a comparison of how the same instance would look like in JSON format and in XML format. Both formats are commonly used by application developers, so it's a matter of preference. A RESTful API can be used to interact with the resource. As noted before, an API, or Application Programming Interface, is a list of commands or operations that a server provides so that any interested client application can interact with a server application. The FHIR operations consist of create a resource, which uses RESTful API command POST, read a resource, which uses RESTful API command GET, update a resource, which uses RESTful API command PUT, and delete a resource, which uses RESTful API command delete. Search, which uses GET, history, which uses GET, transaction, which uses POST, and operation, which uses GET. Each of the FHIR operations are described in depth in the FHIR specification. The FHIR specification can be accessed at www.hl7.org/FHIR. Let's consider the medication management mobile app scenario again. John Smith is a patient who uses this app to manage his medications. The app interacts with his doctor's EHR to determine his current medication list. Let's say his ID number is 1234567. The EHR publishes an API for developers to use, following the FHIR standard. The mobile app would issue a FHIR API call to get all the medication statement resources for the patient with ID 1234567. The FHIR API server that houses the EHR data can be queried. Meaningful Use Stage 3 specifically requires that providers provide API access to patient data to engage patients. The NIST test script for vendors certifying their ONC 2015 technology recommends that they use the FHIR standards. FHIR is designed to be fast and friendly for implementation. Developers can have simple interfaces working in a day. FHIR has implementation libraries in many common program languages, such as Python, JavaScript, .NET, and C#. These implementation libraries mean that there is source code freely available, and developers can use the source code in their products. Many example resource instances were provided to kickstart development, and free test servers are also available that allow developers to experiment. There are many Connectathons events happening all over the world where developers come together, connect, and field test the standards. These specifications are meant to be easy to read, but there are also communities that developers can join to ask questions and exchange ideas. The FHIR programmers find problems as they implement, and the standard is then quickly fixed to support the development community. There are numerous companies and national efforts that have created initiatives to spur on FHIR's progress. The speed of HL7 FHIR standards progress, as well as the developer community's focus, is unlike any other healthcare interoperability standards effort in the past. There is great hope that FHIR will play a key role in interoperable health IT in the future. This concludes Lecture E of Standards for Interoperable Health IT. To summarize, HL7 FHIR was developed due to limitations with HL7 versions 2 and 3. It was designed for the web and to be friendly for implementation. There are many HL7 FHIR resources, and they are freely available. This concludes Unit 5, Standards for Interoperable Health IT. The summary of this unit is that standards are essential to scale interoperability, and there are multiple organizations that develop and/or encourage standards. There are 3 types of interoperability standards: lower level, healthcare content, and terminology. Standards are needed to ensure interoperability, secure transmitted data, describe structure, meaning, and protocol, and are optimized with the use of implementation guides or profiles. HL7 version 2 is a widely adopted general healthcare interoperability standard for messages. HL7 version 3 is widely adopted for its document standards, notably the Clinical Document Architecture, CDA. HL7 FHIR was designed for the web and to be easier for implementation.